Episode 2. What is an IP address? In this episode, we will discover a fundamental in computing. What exactly is an IP address? An Internet Protocol address is analogous to a house address, insofar as it uniquely identifies a host. It sits at layer 3 of the OSI reference model and at layer 2 of the Department of Defense reference model. As can be seen here, the OSI reference model has 7 layers, whereas the Department of Defense model has 4. We can, however, see that layer 3 of the OSI reference model, network, maps directly to layer 2 of the DoD reference model, internet. This episode will focus on IP version 4. I will be dedicating another episode for IP version 6. An IP address is a way to uniquely identify an individual host. It is made up of 4 octets, an octet being 8 bits, a byte, and an IPv4 address being 32 bits in length. Remember, in order to find something, it has to be uniquely identifiable. It was defined in RFC 791, an RFC being a request for comment system used to define, for example, network protocols. I've linked this RFC below. Here is an excerpt from RFC 791. A name indicates what we seek, an address indicates where it is, and a route indicates how to get there. This episode focuses on the address. Further episodes will focus on the name and the route. Your smartphone has an IP address. Perhaps even your fridge or television has an IP address. Anything, in fact, that wishes to connect to the internet must have an IP address, and it must be unique. Now, in order to understand IP addressing, one needs to understand a number of things, such as the binary format and position of bits. So, let us delve into bits and octets in relation to an IP4 address. The IP addressing scheme contains 2 parts. The network part, from the left-hand side, otherwise known as the higher order bits, and the host part, from the right-hand side, otherwise known as the lower order bits. As I've said, this episode focuses on the IP address portion. The network portion we will be looking at in much greater detail in the next episode. A bit is short for binary digit and is the smallest unit in the computing world. There are 2 states, 0 and 1. A byte is 8 bits. Bytes, however, are more commonly used to define such things as storage, speed, or bandwidth. An octet is the group of 8 bits used as part of an IP address. Remember, an octet is 8 bits, and there are 4 octets in an IP address. For our first example, we're going to take the IP address of 1.1.1.1. Now remember, this is in decimal notation, whereas an IP address within the computer is in binary notation. Decimal notation is the counting in base 10, using the digits 0 to 9, whereas binary notation is the counting in base 2, using only the digits 0 and 1. In decimal, each position to the left, counting from the right, represents a power of 10. In binary, however, each position to the left represents a power of 2, as can be seen in the table below. So, remembering that an IP address is 32 bits in length and is made up of 4 octets, and an octet being 8 bits, let us take the example of the IP address of 1.1.1.1.1. Having an IP address represented in decimal notation makes it far easier to both read and write. Basically, the bit value, the bits that have been turned to 1, should equal the decimal value from the actual IP address. So, we count from the right of each octet in binary, which represents a power of 2. Here we can see the IP address of 1.1.1.1 in binary format. As you can see, each octet has the rightmost bit switched to 1. That bit is the value of 1 in decimal. So, for each octet, we have the value of 1, 1, 1, 1. If all the bits are set to 1, we have a value of 255. However, if all the bits are set to 0, we have a value of 0. We will be discussing these numbers when we talk about network masks. This will be in the next episode. As the number of devices and networks gradually increased, it was recognized we needed a way of differentiating between the public internet space and the private business or home network space. To do this, a number of IP networks were chosen to be used and to not be routed on the internet. The maximum number of IP4 addresses is a tad over 4 billion. It is estimated that as of 2025, there are 19 billion Internet of Things currently connected to the internet. Remember, each publicly connected device must have a unique IP address. RFC 1918 was written and designated a number of networks that were to be only used in the private network space and not to be routed on the internet. These are the 3 networks that were chosen: 10 on a /8, 172.16 on a /12, and 192.168 on a /16. No doubt you may recognize some of these, as either your home or your work network will have an IP address in one of these 3 ranges. We will be taking a look at that number after the slash, which is called a slash notation or a prefix, in the next episode. Now, let us take another example and convert it from decimal notation to binary. 192.168.33.77. 192 in decimal requires the 8th bit and the 7th bit to be set to 1, which gives a value of 128 plus 64, which equals 192. The decimal value of 168 requires the 8th bit, the 6th bit, and the 4th bit to be set to 1, which gives a value of 168. 33 requires the 6th and the 1st bit, 32 plus 1. And finally, the decimal value of 77. This requires the 7th, 4th, 3rd, and 1st bits to be set to 1. And here we have the IP address of 192.168.33.77 in decimal notation and written out in its full binary address, all 4 octets, as you can see there. So, what have we learnt from this episode? Well, we have learnt that decimal notation of an IPv4 address is far easier to read and write. that there are 8 bits in an octet. We have learnt that an IPv4 address is 32 bits in size, which we know now is 4 octets, and that there is an RFC 1918, which designates a number of networks to be used in the private address space, such as your home or business. Thank you for watching. If you do like what you see, please like and subscribe. You can also find me on X and TikTok with the handles the_net_nous. In the next episode, we will tackle subnet masks.